Hello guys, welcome on Tesla Eduventures. In this video, we are starting the alternating currents, and first of all, we will be discussing the definition of alternating current and the method to identify the alternating current. So you can see that first of all, let us know that this alternating current are the currents which change their direction of flow after a fixed interval of time. So these currents are called as alternating currents. So it is necessary for an alternating current to change its direction of flow periodically. So we can say that this first current is changing its direction of flow after a fixed interval of time. So this is AC. The second one, this one is DC because it is not at all changing the direction of flow. This one, third one is AC as it is changing the direction of flow. The fourth one is DC that as it is not at all changing the direction of flow. This fifth one is again AC because it is changing the direction of flow, and the last one is again DC. But many students show me this graph and they say that, sir, we have seen that this is the DC current. So this is also DC, but this is constant DC. Okay? And this is a variable DC because it is varying with time. So this is the basic difference between DC and AC. Now we in JEE curriculum are concerned with the sinusoidal ACs. Now the word sinusoidal means that we are concerned with only those currents and voltages which are the function of sine and cos. So you can see that this first one is the function of sine, so it is also it is the current, so I is equal to I naught sine omega t. And this is the function of cos, this is the current, so I is equal to I naught cos omega t. This is a sine function and it is voltage, so we can say that V will be equal to V naught sine omega t. And this is the cos function voltage, so we can say V is equal to V naught cos omega t. Some students say that the alternating current must be the currents only, the voltage cannot alternate. In fact, we can say that alternating currents are generated due to the alternating voltage. So alternating voltage is the source of alternating currents. So alternating voltage also exists in the same way as the alternating currents exist. Now let us discuss the root mean square value of AC. It is also called as RMS value in short. Its another name is virtual value and its another name is effective value. So these three names are of the same current. Now by definition, RMS value of AC is that value of DC which would produce the same amount of heat in the same circuit in the same time. So let me demonstrate an example. First of all, let me tell you that I would be deriving this in this video only, that I RMS is equal to I naught by root 2. So let us assume this now, that I RMS is I naught by root 2, and let us consider two circuits. In these two circuits, this is AC source and this is DC source. The resistance is same in both the circuits, and we have observed that if we flow this AC current from this resistance for some time t, then it produces a heat of H. This is heat produced, and this is time. So in T time it produces a heat of H in this circuit. So I am wondering that how much current of DC should I take in the same circuit so that it may produce the same amount of heat in the same circuit in same time. So this value of DC which would produce the same amount of heat in the same circuit in same time would be the RMS value of AC, and as we have discussed already that RMS value of AC will be I naught by root 2. Now I naught in this example is 200 root 2, so I naught by root 2 will be equal to 200 root 2 by root 2. So I DC which I should take should be the RMS value of AC, it should be 200 amperes. So if I produce a 200 ampere DC in this resistance, then it would also produce the same amount of heat in the same time in the same circuit. So this is the value of AC, RMS value of AC definition, and you would be getting around to some words which will say that we are using AC emitter or AC voltmeter. So AC emitter or AC voltmeter measures the heat developed in the circuit, and proportionally they report the current. So we know that if you will connect an AC emitter to an AC source, then obviously it would read the RMS value of current, and if you would connect this AC emitter to the DC, then obviously it would read the same DC value of current which is already flowing in the circuit. Okay, so this is very important to note that if nothing is said about the emitter or voltmeter, you have to consider that emitter voltmeter as AC emitter voltmeter in AC circuits, and hence you would be assuming the reading of those meters as RMS value of voltage or current. Okay, now let us derive the RMS value of AC in full cycle. Obviously, by default, we are deriving in full cycle. So we know that I is equal to I naught sine omega t, and the full form of RMS is root mean square. But operationally, it is done in the reverse sequence. First of all, the current is being squared. So I square is I naught square sine square omega t, and then we have to find out the mean. So the mean value will be the average value, and the average value of I square will be I naught square sine square omega t dt, integrating from 0 to t, divided by the total cycle time t. So this is I naught square by t, and to integrate sine square omega t, we have to write it as 1 minus cos 2 omega t into dt by 2. The limit would be from 0 to t. And this would be I naught square by t, 2t. And we know that the integration of cos 2 omega t from 0 to t full cycle will be 0. And therefore, the integration of 1 will be t, and instead of t we would apply the limit. So the mean value or average value of I square will be I naught square by 2, and if we find out RMS value, so it would be the root of I square mean. So I RMS will be equal to under root of I naught square by 2, and therefore it would be equal to I naught by root 2. So I RMS will be equal to 0.707 of I naught. So we can say that I RMS is 70.7% of I naught. Okay guys, now if we talk about the average value of AC. So average value of AC is that value of DC which would pass the same amount of charge through the same circuit in the same amount of time. The only difference between RMS and average currents is the fact that in that RMS case we were speaking about the generation of same amount of heat H, and we are speaking about the passage of same amount of charge Q through the same circuit in the same time in the case of average value of AC. So in this case you can see again in this example that there are two circuits in which same resistance is connected to AC and DC sources, and let us suppose that obviously the AC current produces or passes some charge into this circuit in the same time, in the t time, and the value of AC, in fact we can first of all take the example as I will be I naught sine omega t. So let me tell you that I average in full cycle is 0, We will derive this in this video only. And I average in half cycle is 2 I naught by pi. This is in half cycle. So let us take the example of half cycle. So let us see that for half cycle from 0 to t by 2, the charge q passed through the resistance is q, and the time taken is t. So if we are wondering that how much current we should take so that it would produce the same amount of charge in the same time in the same circuit, then this value of current, DC current, will be equal to the average value of AC, which is 2 I naught by pi. So this will be 2 I naught by pi, this IDC, and it would produce the same, it would pass the same amount of charge Q through the same circuit in the same time. Okay, now let us derive the value of AC analytically. So we know that I is equal to I naught sine omega t. So for half cycle, or first of all, let us derive for full cycle. For full cycle, we can say that the sum of sinusoidal currents in full cycle is 0. So I average in full cycle from 0 to t will be integration of I naught sine omega t dt, and limit will be from 0 to t, and it would be 0, because you know that in full cycle average of sine is 0. But in half cycle we can say that I average will be equal to integration of I naught sine omega t dt divided by t, limit will be from 0 to t, and I naught by t is common. The integration of sine is minus cos omega t divided by omega, limit will be from 0 to t, and this will be equal to minus I naught by 2 pi, because omega is 2 pi by t, so we have cancelled that with t, and this cos 2 pi, and this is half cycle, so obviously this is half cycle, so this is t by 2 and this is 2, and this 2 will be cancelled out. Okay, so time is t by 2, and this is 2 pi by t minus cos 0, and this is cos pi. Cos pi is minus 1, cos 0 is 1, so it would be minus 2 in total, and it would be plus 2 I naught by pi. So we can say that in half cycle the average value of AC is 2 I naught by pi. So that's it in this video, guys, and in the next video we'll be discussing more concepts of AC. Thank you.